information being generated. So here, further boundary conditions are generated, and these can be polarized and get further boundary conditions, and so on, and so on, and so on. And I can continue to do this to this system towards infinity. If I give this to my computer, it will continue to make divisions. I could get him to zoom and then keep dividing and zoom and keep dividing and so on to infinity. I would never, ever, ever get to the end of it. However, I would never, ever, 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 ever exceed that first boundary I've started with. So I here can show that infinite amount of information, infinite amount of discreteness, infinite amount of energy can be present in the so-called confine of an isolated system, in the so-called confine of a finite boundary. And then if I zoomed out from that boundary, I would see that that boundary is most likely embedded into a larger one, and 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 so on, to infinity. So I have infinite fractal divisions from infinitely small to infinitely big. And in a system as such, there would be no lack of energy, since there would be infinite amount of information from any boundary conditions that I picked. So this leads to the realization that if we were to write new physics that assume open systems, relationships, then that system most likely would start looking, those physics most likely would start looking like fractal physics, holographic physics, in which all points are in relationship with all other points. All information is present in each part. And taking this view, if I was to look at something like a hydroelectric dam, and I applied the open system conservation law to a hydroelectric dam, I would get something different than what we get today. For instance, today, in conservation law, if we have a lake and there's water coming down that lake into a turbine, oh, bad turbine. Okay, kind of a turbine. And we got plus, minus. And here we have a gravitational potential, right? The water is elevated relative to the turbine, gravitational potential. And the gravitational potential is given to the turbine in terms of spin. The stiction and friction, because of conservation law, we will only extract a very small percentage of, a small percentage of the available gravitational potential, and that will be transferred to electrical power here. Okay? However, the water comes out of the turbine, and in current isolated system conservation law, that's where the box ends. But today, we're going to break the box. So, if we break the box, then we follow the water. And as we follow the water, we realize, wow, it's flowing south because the earth is spinning, and because the sun is shining, and because there is, Coriolis forces. The water that's flowing south is evaporating in clouds. And these clouds that are south, because of Coriolis effect, are coming back north. And when they get up there, it's cold and it snows and rains, and it goes back into my lake. And that was free. I didn't have to pay for that part. Nowhere in the universe is there a toll booth that's, you know, asking you to, like, that's charging your credit card every month to make sure your atoms keep spinning. That would suck. Because they spin really fast, it'd be really expensive. So nature is giving us all the power we have today already. Right? At its most fundamental level, this is given. It is already free energy, if you'd like. What we need to figure out is how to extract it at its source. How to extract it before it's produced the material world. Because if we can get to the source of energy, the source of the energetic universe, and we live in an extremely energetic universe. Look at, I mean, there's galaxies, there's stars, quasars, I mean, even the surface of the sun, I mean, it's extremely energetic there. It's not dead. We're flying through space at thousands of miles per minute. I mean, you know. And there is people on this planet in their isolated system saying, wow, you know, there's not enough energy for everybody. So how do we get to the source of it? First, we got to ask the question. If we look at that system, if I look closely, I would say, but wait, if I keep dividing to infinity, what am I dividing? What is the substance that's being divided? And that leads to the question, what's connecting all these scales? It leads to the question, if I give you all the things in the universe, everything, you got the whole universe, and I said to you, okay, point at something that connects all things. Find me something that's everywhere. You'd have to think about it for a little while, and then you'd eventually go, oh, space. Space is everywhere, right? Space is in between galaxies, between quasars, between pulsars, between stars, between planets, between atoms. In the densest material on Earth, like carbon, you know, like diamond, if you took one of the atom in the diamond molecule and you grew it to the size of an orange, the other orange would be 2 football fields away. That's how much space there is in the material world. Actually, you know, and many spiritual people say, oh, it's so dense over here. Nah, not really dense. And actually, these were the last words of Buckminster Fuller on his deathbed. It's like, he realized, and I'm sorry to say that, but you know, nothing touches. Like for your partner, that might be a problem, but you know, nothing has ever touched anything. Atoms are very far away from each other. When I touch this podium, my atoms in my hand are not anywhere close to touching the atoms in this podium. If they did, there'd be fusion, there'd be all sorts of gamma ray emission. There'd be some serious issues. There's large distances at those scales. All that's happening is that there's a little electromagnetic field here that's not in phase with this little electromagnetic field, so can't get through it. But if those were in phase with those, my hand would go right through it. No problem. Question of phase. But as well, if we look even deeper than the molecular structure, if we look at the atomic level, then we find that the atom itself is made out of 99.9999999% space. Mostly space. The material world we live in is space with a little jiggle, 0.00001% that we pay a lot of attention to. That is the little jiggle that we call reality, the real world. Physicists told me one day after one of my presentations that I didn't live in reality. I said, thank you very much. Because we're made of vacuum. And, you know, it appeared to me early on when I studied a little physics in high school that, wow, maybe it's the other way around. Maybe it's not matter that defines the space, but maybe matter is defined by the space. Maybe it's the space that defines the atomic structure. Maybe the medium is space, and the atom is just a little division, a little oscillation of that space. Maybe space is what connects all things. Maybe space is what organizes everything. Because that's a problem in physics. The incredible organization we see in nature everywhere is not trivial. It really isn't. You can't just account for it by random functions. It doesn't add up. If you do the math, it doesn't work. If the universe was random, in 13.7 billion years since the Big Bang, we wouldn't even have a little blade of grass with all the little microbial life and DNA and all this stuff in it. That would be too complex. Let's go back to our jumbo jet. It'd be equivalent, actually, it'd be easier to take a jumbo jet into its smallest bits again, and let's not freak out the engineer this time. Take all the bits, there would be a lot of bits, and threw them up in the air, and assuming that by the time it comes back down,